This is Josh White with JW Math Tutoring. In today's video, I'm going to go through the Math Module 1 of Bluebook Practice Test number 7. So let's go ahead and get right to it.
But life is a dream the calculus could never predict.
Here's before I begin going through this brand new Bluebook Practice Test 7, the math part, Module 1. Just want to mention a couple things. First of all, if you like this video, of course, please do give it a thumbs up, subscribe to my channel, and sign up for notifications. Second, I like to show as many methods as possible to solve these problems. So that may mean for a specific video, I might go over the time limit, that's allotted for each section of on the math part of the test, the 35 minutes. So just keep in mind, obviously, if you were taking this test, um, as an actual test, an official test, you wouldn't necessarily need to do all of these methods, on the various multiple problems that I demonstrate them on. And then finally, also check out the videos for Module 2A and Module 2B for this same test once they are posted. All right, so that being said, problem number 1. Here we have basically a word problem that you're going to interpret or essentially create a linear function from the text that you're given. So basically the total cost is $9.60, so that's why those equations are equal to $9.60. The box of cereal is $2, so you're going to add $2 to the total amount that's paid for strawberries, and the strawberries are $1.90 per pound, and he's buying p pounds, so the cost for the strawberries is going to be 1.90 times p. So right off the bat, you can get rid of these two. These are obviously incorrect. And then if you're left with the first two, notice it's got to be 190p plus 2 to get the total cost of it. So the correct answer for this one is just letter A. All right, so this next question, you just have a basic function problem here, and you're just asked to evaluate this. So all you're going to do is you're just going to plug in 2 for x, and then just see what it comes out to. So I would just go to the calculator, and you could just do 25 times 2 plus 30, and you get your answer there. It's 80. Or you could, if you want, just type the function actually like this, and then on the next line, you could just type f of 2. Okay, and you could get 80 that way. So either of these options are acceptable, but the correct answer for this is just going to be 80. All right, now for the next one, number 3. Here you have a graph. They're just asking you to interpret the meaning of the y-intercept. So the y-intercept, you should be able to see it's right up here around 225. So what does that mean? Well, it just means that the initial value or starting value, that's what the y-intercept is, of this tablet was $225. So the correct answer for this is just going to be letter A. Next, you have an absolute value equation. So you can solve this by hand, of course. You subtract 61 on both sides, and that gives you the absolute value of P equal to 4. Therefore, P is either going to be equal to positive 4 or negative 4. But negative 4, of course, is not an answer, so we would not consider that, and you would just get positive 4. So the correct answer is going to be B. But of course, you could just go to Desmos and do this entire thing in Desmos. I mean, if you wanted to, you could just type this out. Now you have to change it to X, of course, in one thing, and you can see the vertical lines at 4 and negative 4. But if you weren't sure exactly where they are, then you could do my alternate approach, which is to do y equals left side, y equals right side, and look for the intersections. Now the thing is, you're going to have to zoom out a little ways, but here it is. The intersections, which are the solutions, are at 4 and negative 4. So we only see positive 4. That just confirms the correct answer is letter B. Next up, we have two triangles that are given as congruent. So all you need to know here is that angle E corresponds to angle J. Therefore, whatever the measure of angle E is, the measure of angle J will be the same because they're corresponding angles, and in congruent triangles, the corresponding angles are congruent. So J is going to be 45 degrees. The correct answer is B. You don't need to do, any more work than that. Next up for 6, here you have, try to zoom out, see if I can get some of the graphs on the screen, at least more than one. This is the graph of this ball being launched from a platform, right? Then it's launched from a platform that's 2 feet shorter than the first one. So that means instead of starting at 7 feet, it's now going to start at 5 feet because 5 feet is 2 feet shorter than that. So we're looking for the graph where the y-intercept is 5. So if we look at this first one, notice here it starts at 4, not 5. Okay, so this one is wrong. Ignore it. We can look down here at C. We see here it starts at 7. That one will be wrong. B starts at 5, so we keep it for right now. And then if we scroll down and look at D, notice this one also, it starts way up at 14, so that's not right. So the correct answer for this problem is just going to be letter B. Next up, we have a fill-in question, student-produced response, and we know that the ratio of x to y is 9 to 5. So now we can fill in for x, which is what corresponds to the 9, its actual value of 162, and then we can solve for y by basically just cross multiplying. So you cross multiply this, you get 9y equals 5 times 162, which is just 810. And then you go ahead and you divide by 9. So for y, you end up getting 90. So the correct answer to this problem is just 90, and that's pretty much all you need to do for it. Next up, we have question number 8. Here you have an equation, and notice that on the right side you have 1120, which represents a number of points. Okay, so that means each of these entire expressions here have to represent points. 80s is a total number of points. 90c is a total number of points, from circle tokens. So how many points is a circle token worth? Well, if c is the number of tokens, then 90 is the number that each token is worth, because we take 90 points per token times the number of tokens, and that gives us a total number of points. So the correct answer to number 8 here, oh wait, sorry. How many more points, I'm solving the wrong thing. How many more points is a circle token worth than a square? So sorry, circle is 90, as I just said, but we actually want to know the difference between the circle, which is 90, and the square, which happens to be 80, the coefficient in front of the s. So this one's asking for the difference between the two. So the correct answer is going to be letter D, 10. Circle is worth 10 more points than a square token. Now for number 9, this one there's multiple ways you could solve it. So if you want to do it by hand, okay, note that the x plus 9s here technically cancel out, and then you just have the equation x minus 9 equals 7. So we just add 9 to both sides, and we get x equals 16. So the correct answer for this is going to be letter C, 16. Now, you could, of course, solve this in Desmos. So if we go back to here, Desmos, and you can plot out the left side. Okay, except I need to get rid of this and put the y equals there. Okay, so we got the left side, and now we can do the right side. Where do they intersect? Right here at an x coordinate of 16. So that's it. That's all I have to do. You could also, if you wanted to, like basically plug in the answers. So you could say, okay, here's my function. Actually, let me do it this way. It'll be easier. Okay, here's my function. And you could just go through the answers and say, okay, if I plug in 7, do I get 7? No. If I plug in 9, do I get 7? No. If I plug in 16, do I get 7? Yes. So that's a third way you could do it. That's basically back solving right there. All right, let's talk about this formula here. All we have to do basically to solve for c minus b, if you notice here, is just subtract b from both sides. It's literally just one step, and then c minus b is just going to equal 12t. So the correct answer for this is just letter D, and that's it. Next up, number 11, another fill-in. This one, there are actually three different answers you could submit. You have basically three x-intercepts for this graph. Because x-intercepts are the same as 0, same as roots, they're where the graph equals 0. So basically, you take each factor and you set it equal to 0. X minus 14 equals 0. You solve that, you add 14 to both sides, and you get x equals 14. So that's one possible answer. And then you do the same with the other two factors, and you're going to get -5 and -4. So there's three different answers you could submit. I'll just submit 14, but again, you could also put -5 and -4. And of course, you could just go to Desmos and you could just graph out this function and just get a y-intercept from there. Here's 4, here's -5, and right over here is 14. Okay, so again, you could get any of those three right from there. All right, let's talk about this one next. So obviously you could evaluate this by hand. And if you do that, you probably notice that if you plug in 1/4 for x here, because all we're doing is evaluating a function, 1/4 minus 1/4 is 0. 0 squared is 0. 0 times 5 is 0. So this whole thing basically drops out, and the answer is just 11/4. And that's it. You could also put it in as the decimal 2.75. If you want to do it that way, that's fine. Now, of course, you could also just go to Desmos and we could type in the function. Here's the function. Okay, what is f of 1/4? And see, it gives me 2.75, which is fine. Or if you want the improper fraction, you can get 11/4. So either way, all you have to do is just, again, evaluate this function. Right, next up, we have question number 13. Here they give you the equation of a circle, and they just want to know what is the center and what is the radius. So hopefully you are familiar with standard form. It's x minus h squared plus y minus k squared equals r squared. So the h value in this is just going to be 13 for our center. The k value is, in this case, just actually the letter k. And the radius value is the square root of the number on the right, because the number on the right is r squared. Therefore, r is equal to the square root of 64, which is just equal to 8. So the correct answer for this one is going to be letter A, center 13 comma k, and radius equal to 8. All right, next up we have question number 14. Here we have another circle problem. You're given its radius, you're told its area is equal to, whatever, and want to know what the value of this constant b is equal to. All right, so we know the formula for area of a circle is equal to pi r squared. So we can just plug in the radius of 2.1 and we can square that. And when we go ahead and do that, the area will come out to 4.41 pi, and that's just equal to b pi. So if you notice, you can just divide by pi, or really the pi's just cancel out. So what's the value of b? It's just 4.41. It's just basically the square of the radius. That's all they're looking for. So that's the correct answer. And we can move on to the next question. All right, here you have a graph, basically a scatter plot. and they want to know the average rate of change from x equals 5 to x equals 7. So that's really just finding the slope, y2 minus y1 between these 2 points. So right here and right here. So our two y values are 24 and 14. Our two x values are obviously 7 and 5. So we just go ahead and subtract them. We get 10 over 2, which is just equal to 5. So the average rate of change between these 2 points is just 5. That's what we would type in as our answer. And we can move on to the next problem. All right, here you have a system of equations. So there are actually, I guess, technically two different ways to do this. I want to know the value of 39x. So the quickest way is to just add these together, because notice you have 3y and negative 3y. So if you add both equations together, you just get 13x minus 6 equal to 0. And then you add 6 to both sides. And now, because they want 39x, again, the fastest way is to just multiply both sides by 3, because that will turn the 13x into 39x, and so therefore you get that it's equal to 18. So the correct answer is D. However, if you don't see that or understand it, that's fine. You can instead just divide by 13, and you can get x equals 6 over 13, and then you can multiply the whole thing, that value of x, by 39. And again, you could do this in Desmos. You don't have to do this by hand, but 13 goes into 39 3 times, and you get 6 times 3, 18. Okay, so now let's say you want to do this in Desmos. So let me first clear off the screen. So you just graph the two lines. All right, and we see here the value of x. Now here's the problem, okay? The problem is the value that you get for x, which is technically 6 over 13, it's not an exact value. And even if you export like the point here, let me just try to delete. There we go. So we have this value. See, it's not giving us the 6 over 13 that we're looking for. So like, see, if you try to multiply this by 39, okay, whatever, get rid of that. It's like 18.0006. So most likely you would be able to determine that, okay, the answer has to be 18. Because none of the others make sense. And this is a multiple choice. However, if it wasn't a multiple choice, I guess really it technically wouldn't matter, because if you'd still enter 18.00, that would fill up all 5 spaces, and that would be marked as correct. However, here's what you can do. Here's the correct way to do this, solving the system of equations where the x value is not a nice integer. All right, so what we have to do is the following. This, by the way, you can learn how to do this in my ultimate Desmos guide to digital SAT math. It's basically solving a system of equations using regression. All right, so what I'm going to do is I'm going to type the two left sides in one set of brackets, and then I use my total for regressions, and I'm going to type the two right sides. These are separated by commas. I'm using x1 and y1, but you could use other letters. You could use A or B or C or D or whatever, but if you use x and y, you have to use x1 and y1. Okay, so I get an answer here. It is the only answer because I just graphed it and I saw that there's only one solution. So now I want 39x1. Notice it gives me exactly 18. There's no 0.0006. There's no decimal to it. This is because x1 is storing the exact value even though you only see 6 decimal places to it. So this is how you would solve a system of equations where the solution point has a number or numbers in it that are not integers, and you can use that exact value for later calculations. All right, next up, question number 17 is just basic properties of an exponential function here. How long does it take for the population to double? So, of course, the theory behind this is just that basically when you have a problem like this, so 40,000 is obviously our initial amount, 2 is our base. If you have a number, 790, which is divided by your variable, in the exponent, this number right here is essentially going to be your doubling time. And of course, for doubling time, we need to have a 2 down here in the base. If you have a different number, then it's not going to be that exact number. It's going to be slightly different. But if you have a 2 as your base, this number is just going to be the doubling time. Okay? Now, to show the reason why, I'm just going to go to the calculator. So the answer is going to be B. So if I go to the calculator, all right, so can't type in the comma. There we go. Obviously, you won't see this thing because it's going to be way off the screen. Yeah, there's the graph right there. Look, we got to zoom so far out. Okay. So now, if you start, let's say you start with x equal to 0. So the easiest way I'm going to do this, just to do all these different calculations, I'm going to make this f of x. Okay. So initially, we have 40,000, right? Now, you could just go through the answers and you can notice what happens. So if I plug in 2, has it doubled to 80,000? No. If I plug in this, yes, it doubles to 80,000. So that just confirms this is correct. The reason that's happening is because, when you plug, just say a 790 in here for the t, notice it's 790 over 790, which just simplifies to 1. So now we have 40,000 times 2 to the first. So therefore, the 40,000 is now being multiplied by 2, whereas if you compare it to t equals 0, 2 to the 0 is just 1, so that's why it was 40,000 initially. So the point is, for every 790 minutes that you increase the t value by, you're going to cause the 40,000 to be multiplied by 2 to the first, and then another 790 would be 2 to the second, another 790 would be 2 to the third, and so on. That's why 790 is just the doubling time for this problem. Next up, number 18, we have an equation, and again, I will show you the quickest way to solve this, but it's not the most intuitive or straightforward. So the quickest way, and they like to do this a lot, where they don't ask you for x, they ask you for some expression with x, and the expression happens to be in the problem. Notice right here, 2 minus 4x, is in the problem. So the quickest way to do this is you add 8 parentheses 2 minus 4x. You can just treat it as you can treat it as one term even though it's not. And when you do that on the left side, you just add the coefficients in front, negative 7 plus 8. So you get 2 minus 4x, and it's really just a 1 in front that I'm not going to write. And then you can move the 5 over to the right side. And so you get 2 minus 4x equals 11. Therefore, correct answer is 11. That's what we would type in. Now, if that's not obvious, that's fine. Just go ahead and solve the problem. I would probably recommend doing a Desmos, but I'll show it by hand first. So, just to go through all the steps, distribute the negative 7, and then distribute the negative 8. Let's just check my notes to make sure I've done everything correctly here. So we should have negative 9 plus 28x equals 32x. Yep, negative 9 equals, now subtract 28x, because these cancel out, they're 0. 4x, divide by 4, x equals negative 2.25. Okay, it should be, no, that is right. Yep, it's negative 2.25 or negative 9/4. Now you just plug in 2 minus 4 times negative 2.25. Here I would just go to Desmos, but whatever. This just turns out to be positive 9 because it's 2 negatives. 2 plus 9 is 11. Okay, so we get the same answer here. Now just to show you, if we go to the calculator, and the way I like to solve equations is I type y equals left side, y equals right side. Look for the intersection. Okay. These things have ridiculous slopes. Okay, where is my intersection point? There it is right here. Negative 2.25. And then what you would do is you would just say 2 minus 4 times negative 2.25. And you get 11. Okay, so that's how you do the problem entirely in Desmos. Next up, we have question number 19. So this problem, you're dealing with basically percentages or an increase by a certain percentage over a certain period of time, and basically they want to know what was the starting amount. So essentially, January 1st, there were some number of dragonflies. February 15th, there were 99. January 1st, don't know. That's what we're trying to find. February 15th, there were 99. They tell you the percent increase was 12.5%. So you can set up an equation to do this if you want. Basically it's like x is your January 1st starting amount plus 0.125x. That's the 12.5% increase. And that equals 99. And you get 1.125x equals 99. And then we end up with x just dividing these equaling 88. So the correct answer for this is letter A. But again, this is another case where it is actually, I think, much quicker and much faster, easier just to go straight to Desmos because you can just type everything in basically one step or one line. So you could start with the answer choice. So you could say 88%, sorry, 88 plus 12.5% of 88. And right there, it gives you 99. Does that match the answer? Yes, it does. That's why it's a correct answer. So if you wanted to change it, you could just change the 88s to 87s, and you could see, well, it's not 99. That's obviously wrong. And 12 and 8, you can see are just going to be way too small, to get 99 by the time you add the 12.5% increase. So that's how you could do the entire thing, just in Desmos in whatever that was, 10 seconds, 15 seconds. But again, correct answer is A. All right, next up we have number 20. So this one I will show you how to do it using the quadratic formula. That's what I call the traditional method. Then I will show you how you could actually do the entire thing in Desmos. So quadratic formula, we're going to do the negative b sub negative 8 plus or minus square root b squared minus 4 times a times c all over 2 times a. So we've got an 8 here, we've got a 4 here. So notice those match the format of the answer. So that just tells me that the k value is just going to be whatever this number is. We don't need to end up simplifying it or pulling anything out of the radical because we're not reducing the 8 and 4 in any way. So this is 64. This is 4 times 2 is 8. 8 times 7 is 56. And the negative and negative mean that it's going to be positive. So this is going to be 120. Therefore, the correct answer for this problem is just 120. That's what you would type in. So now let's go to Desmos and just confirm how you can do the problem entirely in there, basically using regression. All right, so the first thing we're going to do is I'm going to type in the original equation, but I'm going to use x1 instead of x because I'm doing regression. Again, if you want to learn more about regression, check out my Ultimate Desmos Guide to Digital SAT Math, particularly the intermediate and advanced sections. All right, so now what I have to do next is I'm going to define x1 and set it equal to that expression that we're looking at. Basically the 8 minus square root k all over 4. So now what it does is it basically goes back to the regression statement and it forces it to find the value of k, which makes, which will, in this formula, which will match the value of x1 that essentially sets this equation equal to 0. So right there, it gives you 120 and, that's your answer. That's how you could do this entire problem or any of these quadratics where it like gives you the equation and it says, one solution is of the form, something plus square root k over something, anything like that. This is how you can do it entirely in Desmos. All right, next up, we have question number 19. Here it's asking about the x-intercept of a graph. So the function is just going to be, f of x is 19 more than plus 19, 4 times a number. So this is just 4x plus 19. So the x-intercept, that is the point on a graph where the line intersects the x-axis. In other words, where the y value, the y coordinate, is equal to 0. So if you plug this 0 in for f of x or for y and you solve this, you get x equals negative 19 fourths. So the x-intercept for this particular function is negative 19 over 4. So if you go through the answer choices, C and D are both talking about basically like the slope or something, of the equation. That's not what the x-intercept deals with. So, and then we look at A and B. A is the correct one because when the y is 0, the x-intercept is this value. B is the opposite. B is talking about the y-intercept because that's when x is 0, the y, the function is equal to that. That's the y-intercept. That's not what we want. We want letter A here for the correct answer. All right, last question. So this, when I first went through it, was a tricky question because I immediately recognized that this is equal to the sine, sum of two angles formula, sine of A plus B. However, that's not what this question is asking about. That's not in the scope of the SAT digital math section. That is not something you're expected to know. The trig identities, other than very basic ones. So that is not what applies to this problem. The actual kind of like property or rule or topic that you're applying to this problem is that basically the sine of x is equal to the cosine of 90 minus x. In other words, the sine of an angle is equal to the cosine of the complement of that angle. So what you do, or what you notice, is 24 and 66 are complements. They add up to 90. Therefore, you can replace this with the cosine of 90 minus 24, which is just the cosine of 66. And when you look at the second expression, you can replace this with, again, the cosine of 90 minus 66, which is just 24. So you end up getting cosine of 66 squared, because you have two of them multiplied, and then plus the cosine of 24 squared. So the correct answer for this one is going to be letter D. No, why did I just choose that? Sorry, it's C, not D. C has the sine 24 squared in. I looked at the wrong answer choice. It's C, not D. Okay. Now you could also just get this in Desmos as well. So if we go to Desmos, first we need to make sure, click the gear icon, that we are in degree mode. So you could type this whole thing out. Okay, so notice this whole thing happens to be equal to 1. Then you could go through answer choice A. Is this equal to 1? No. Okay, answer choice B. Is this equal to 1? No. All right, now let's look at answer choice C. Is this, or actually, sorry, this is D, which is not equal to 1. But now if I change this, there we go, to answer choice C, where I have the cosine in the second one, yes, this is equal to 1. This confirms that C is the equivalent expression to the one that's given in the problem. All right, so hope you enjoyed the solutions and answers to these problems from Digital SAT Practice Test 7. Brand new practice test just came out 2 days ago on February 3rd. If you have any questions or comments, please do leave them below. Otherwise, if you like this video, please do give it a thumbs up, subscribe to my channel, and sign up for notifications. Otherwise, be on the lookout for the full solutions and explanations to Digital Practice Test 7 Math Module 2A the easier of the 2 second modules, and then after that, module 2B, from the same test, the harder of the two second modules.